Hello, everybody, and welcome to the fifth of our HPC Perspectives Live. My name is Sharon Howe, and I'll be your host today as we continue to explore HPC topics. So throughout the series of these HPC Perspectives, we're hosting discussions, and I'm introducing you to a number of people across our group who will share with you on different aspects of our AI, HPC, and cloud solutions business, and give you some insights of the teams and technologies that make that happen. So today, I'm very pleased to introduce Xavier Vigouroux. Xavier joined CGG last year as a business development manager, focusing on AI and scale up. So he's got a PhD in computer science and has worked for various computer and technology companies, including HP and Atos. So welcome, Xavier. Thank you for joining me today.
Hi, Sharon. Thanks for the invitation.
So great. So today I'm really excited actually to be doing a deeper dive into AI and machine learning. So I've been following the CGG's AI lab for a few years. So I've certainly seen some of the potential opportunities, but a good number of challenges as projects move from that kind of proof of concept phase into production phase for AI. But let's not get ahead of ourselves too much. And before we deep dive into all things AI, Xavier, maybe tell me a little bit more about yourself.
Yep. So, in fact, as you mentioned, my current role is business development manager for AI and scale-ups. So, scale-ups, in fact, are the company that are no longer startups, but that are not yet in a safe situation in terms of growth. So, they have to find the right partners on the side to continue the journey. So, in this context, in fact, I am focusing on these companies and identifying opportunities, generating leads, and developing relationship with them. So I have to assess the needs and find the right offer for them. And before joining CGG, in fact, I spent most of my career in HPC, in supercomputing. So I worked for companies like Hewlett-Packard, this was the name at this time, Sun Microsystems, that doesn't exist anymore, and Bull and Atos and the French companies. So globally, during my career, I was trying to keep the balance between the technical aspects and the business aspects. So because of my PhD, I was always pulled back in this technical aspect. So I tried to keep that. And sometimes I'm on one side, sometimes I'm more on the other side. So, and during my career, in fact, having a PhD was quite an opportunity. Sometimes people are wondering if a PhD is useful for the industry. And in my case, it is, because I joined Sun Labs for almost 2 years, and working on nice project. And also, I have been able to join a AI research center close to Grenoble, belonging to a Korean company called Naver, in fact. And this is where also I ramp up more in the AI.
So is that where your interest in AI start, or was it seeded from an earlier time?
So in fact, yes, my PhD was in last century, in 1995 or something like that. So I'm quite old. And during my master, there was already what we were calling a neural approach called multi-layer perceptron. So this was somehow a very, 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 very reduced version of what we can see today, with few neurons, but the neurons were there. And in fact, the computing power was really the limit. If you look at that, when I was in master, in fact, the most powerful supercomputer in the world, the number one in the world, was 1,000 less powerful than the current GPU provided by NVIDIA. So we can see the huge gap that there is in terms of computing power, and this is what enabled somehow this AI that as we know today. But nevertheless, even if the power was quite small and shrinked, the multi-layer perceptron was quite efficient. For instance, I did an internship already at this time, last century, on the prediction of the pollution close in an area, Lyon, and I was comparing the statistical approach, which was quite regular, with the neural approach at this time. And there was still a topic as the one we are seeing today: what is the best architecture that we can find? How we can tune the hyperparameters to have the right training, etc. And in fact, I was using a genetic algorithm at this time to select the best architecture. So in fact, I was quite lazy. I was just throwing a bunch of experience with different hyperparameters, and then finding the best network, finding that was providing the best result for the pollution. And if this was useful at this time. I'm very, very cautious when I'm comparing what I was doing in 1995 and what I'm doing, what exists today. There is really, the scale is totally different. There is a matter of 1 million difference in terms of scale between the two generations. So there is no way you can estimate what we are producing today from what I've learned in 1995. So today we have the training data. The state of the art also progressed a lot, and obviously, seriously, the current period is simply amazing, simply amazing.
It's quite interesting to think about just what's changed over those last 25, almost 30 years, but what actually also remains consistent. I mean, we've seen so much happen in the last, just in 2023, AI hit the news so much. I mean, it seemed to be a little bit of a turning point after the launch of ChatGPT, kind of in, I guess, late November 2022.
So in fact, ChatGPT has been brought to the public domain or the public attention. But there was a trend already existing for a while. This is really the result of decades of research to make the state of the art progressing. So if you look at ChatGPT as we know today, in fact, it comes from the translation. If you decompose what ChatGPT is doing, you can see the similarities with the translation. You have a sentence, something that you have to understand and to encode in such a way that you can decode it and generate some text based on that. So the idea behind that is so to first encode the meaning and the context that you have, and for the translation this is really important, and then from this context you have to generate some things. And so you have these both sides, and we can find these both sides on GPT. For an instance, the very hard limitation of the previous methods with what we were calling recurrent neural network, LSTM, so long short-term memories, etc. The issue is that they were it was very difficult for them to encode the context. And the context is what is really, really important for GPT to understand things. If I say the word trunk, if I say the word hood, or if I say the word not, you don't know at all what I'm speaking about if you don't have the context. And this is where this is very difficult. And the big breakthrough has been from a paper in 2017 called Attention is All You Need. And this is where this context has been encoded correctly, and we have been able to generate text based on that. And GPT, or the transformer architecture that was described, that led to GPT, and which is the core of ChatGPT. So this is really this architecture that you can see. So first encoding, natural language understanding, and decoding, which is the generation. So, but from this architecture is quite complex. I will not get into details about the head, attention head, all these things. It's quite complex. And the quality of GPT, in fact, of ChatGPT came also with the number of parameters, number of the complexity of the architecture itself. So if you look at today at GPT-4, which is the core somehow of ChatGPT, there is 1.8 trillion parameter inside. This is simply gigantic. And if you compare that to, for instance, the human brain has only 85 billion neurons. So you can see the order of magnitude is totally different. And if you think about everything we can do with our brain and what we can do with GPT, in fact, there is also huge difference. So today, this size is really gigantic. There are a lot of things, but I am pretty sure there is a matter of efficiency behind that. We can consider that somehow we say, okay, let's do something huge and we will have something working, and it works fine. But there is a matter of efficiency behind that. If you look at the power consumption and all the impact to train and to use these models, in fact, you can see that we are currently maybe reaching a limit. And this is why, if you look at what we are doing at CGG, we are looking at this efficiency. When I say efficiency, I don't want to qualify it too much, because this is a matter of time to result, energy to result, for this kind of thing, or latency, throughput. There are maybe aspects, but this is really something we have to focus on today. We cannot go so far and sustained this trend as we are following today.
Yeah, it's a huge trend. I mean, I know you've been talking about Chat GPT in particular, but this really refers to any sort of any of those large language models that we see talked about today. I guess in previous episodes, I know that just the one we did in November, we heard from Jean-Marc Denis as we explored some of those trends that we're seeing in HPC, and we discussed cloud hybrid and the rise of AI and LLMs, and with a growing focus of doing that responsibly. You've talked about just all of these kind of the size of the fires, the billions of operations that are needed there. Um, at that point, we're about to go to supercomputing, and those responsibility themes seemed pretty prevalent there as well. Um, what does how do we do this responsibly? What does that really mean?
So I would say that there are two aspects for that. When you say we are using the word responsibly, the first responsibility, for me, the first one is with regard to the society. There was a lot of discussion about the bias, the toxicity, the fake, the plagiarism, I think we say in English,
Yeah, prejudice.
and yes, all these aspects that once we have a technological tool, what will be the way that it will be used. There are nice way to use it, and there is always a dark side of it. There is an example which is nice. It's when you look at Facebook, that has been used to organize parties in Harvard in 2024, something like that. When I say 2004, something like this, yes. And this was the goal was just to organize party for young people, and it was nice. And in fact, if you look from in 2004 to 2016, where Facebook had impact on the presidential campaign in US, I don't see how we could have anticipated such an impact with this technology. And this is exactly the same thing for the AI. We are unable to anticipate that. Just and as an example, because this is something that occurred to me. In fact, I have been dubbed by a fake website. I wanted to buy a watch for my sports, etc. The price was great. I said, okay, let's buy it, etc. And in fact, this was really a totally fake one and really perfect, in perfect French, really nice wording, etc. I'm pretty sure it has been generated by AI. So responsibly, this is again with regard to the society itself. And today, there are a lot of research done for the explainability, how you can explain the decision, how you can measure the bias, the toxicity. For instance, there is again a data set that is used to measure how the bias is in the encoded again in these models. And there is a nice data set called We Know Gender. In fact, testing how you can see the bias in terms of gender. And for AI, most of AI, doctors are men and nurses are women. That's like this. So we have to change that. We have to measure that, and there are a lot of researchers done to correct the bias which is in the data somehow. Because this is related to the data.
And then, of course, one of the ways of reducing bias in your data set is to ensure you're training on, I guess, sufficient data, which then means more data. It then means more number crunching as well as part of that, and that sort of helps. Well, it hinders this growing model problem.
Yes, because in fact, as I mentioned, there are so many parameters in the models. They can learn everything. They can learn every single information in the data, or try to learn the data set. So they can learn every detail. So if there is bias in the data set, there will be bias in the generated model. So we have to find a way to correct that. And I know some people working on the way based on statistical approaches to find a way to cure things and to say there is no reason why this should be this answer compared to this one. And who knows, maybe AI will be less biased by the human themselves. We'll see, but I'm not pretty sure. And regarding, to go back to the question about responsibility, in fact, there is the second aspect I wanted to mention. This is the fact also that the models are growing, or have grown, before, and today it really has an impact because the quality comes with the size. And you must realize that when we are speaking about ChatGPT, we are not speaking about just one train. We have trained one ChatGPT once or GPT once. We have made many attempts to find the right parameters and to be sure that everything has been tuned to get the best performance and to be better than the already existing models. So Sam Altman, who is the CEO of OpenAI, which is the one who trained the company which trained GPT-4, in fact stated that GPT-4 has costed the cost of the training of GPT-4 was more than $100 million, just the training. So we don't know exactly what is under this umbrella. If there are human resources, the buildings, everything, but this is really unachievable by most of the companies. Only few in the world are able to do that. So, and on the other side also, because we have trained the model, that's great, but somehow the goal is not to train a model. The goal is to use this model for the production and for the inference. And again, because of the size today, being able to do the inference, to use the models, costs also a lot of energy. So again, GPT-4, again, requires 128 H100, so the latest NVIDIA GPU. So if you remember what I've said about the largest supercomputer in the world in 1993, it's 128,000 times more than that. So this is not sustainable in terms of money and in terms of impact on the planet, CO2 and electricity. This is really more than what we can sustain, and just because we will get 1% better results than the previous one, it's not sustainable. So today, again, for the responsibility and to reduce this impact, there are a lot of works in way to shrink these models. So really a lot in terms of architectures, in terms of how the numbers are stored. For instance, we are using we are encoding the numbers with less precision in number format in the floating point. So there are ways to prune, what we're calling pruning the network and change. So there are a lot of techniques somehow to fight against this impact about the current model.
Yeah, this huge, ever increasing kind of volumes of model. So you've talked a little bit around, what you can do with this certain with reducing the size of the model, but there's also an element of what hardware and infrastructure that's being run on, and then as well, I guess, in terms of energy efficiency, in what region that's being run, what energy mix is being used to power that. You mentioned there that the cost that it took to train Chat GPT, and I think when I was having a look, the equivalent, what they estimate the energy for that is equivalent for sort of 7,000 families would consume in a year. That's a huge amount of consumption. So where we're actually running these models makes a big difference, really.
It makes a real difference. The food chain is important. Where you are running it and how efficient you are to run it, and what is the benefit of running it, obviously. So if you look at data centers, for instance, if you got free cooling, if you've got the cooling is much more efficient today than what it used to be with the cracks and all these things. So today we can use warmer things, we can do immersive cooling, for instance, as we are doing. So there are a lot of way to improve things. But again, this is only multiplication factor by multiplication by factor. So if you put 1 watt, in fact, in the CPU to produce the result, how many watts you have put around that for the data center? And again, downstream, how this watt has been used inside the silicon just to get the result, the production that you want. So somehow, what's important is the outcome that you will have. What is the outcome and how many watt upstream at the really top, embedding everything? What is the cost of one outcome?
And I guess in that cost, we're not just including the power in there, particularly with data centers. We've got things like sort of the water usage efficiency
Yeah,
that will
yeah.
become one of those metrics that will become more, as we go forward, will become much more important for data center as well.
And just one additional word also, what is the hardware you will have to change when you move from one generation to another? If you take a full rack and then when you want to move from one generation to another from the CPU, then you have to trash everything. This is not sustainable. So we have to find a way to be sure that the life cycle, the full life cycle from the production to the dismantlement of the infrastructure, everything is as I would say as greedy as possible. Frugal as possible.
Yeah.
It's better as frugal as possible.
The things that are, I don't want to call them disposable, but the things that get changed, so the chips, they're as light and as a smaller part of that kind of disposable part as possible. On that vein, we see chip manufacturers focusing a lot on the specialist AI chips. Is this a good thing? Is this sustainable?
Yeah,
What's
yeah.
your
This
take?
is this is a good thing because you will have the hardware dedicated to a task. And as I mentioned, for instance, about the precision of the numbers, the format we are using is 64 bits, which is what we were using for decades. And in fact, AI doesn't need at all this size of this precision. There is no need for such precision. So today there was a trend for several years to decrease the precision of the stored format for the parameters I was mentioning. So instead of 64, we can go down to 32, 16, 8, and there are even things that people are going even lower, but this is normal floats. This is quite a particular architecture. So there is a lot of creativity, I would say, for the way we are storing the numbers for the AI. And obviously, the chip makers are trying, in fact, to find the best architecture, considering that we don't need any more 64 bits, or because AI is driving the business. So if we want to be efficient of AI, if we want to reduce the watt used for the training, then we have to have the dedicated hardware for the training. Today, at the current state, this is NVIDIA, which is the clear winner and the clear leader because they have worked for many years about the best architecture. They often optimize that, and they have driven a lot of software to be sure it's efficiently ported on the architecture. But again, today they start to have a legacy from several years before. They start to not be fully efficient compared to what we can find in the AI. So today newcomers are coming are appearing with really specific hardware used for specific tasks. So you can see the one that are even focusing on the training, some other are even only focusing on the inference themselves. So today, the point is that we have, and this is great, I love it, there are a lot of different architectures. It's not a single one. There is a lot of different architectures. So the next question that we have is the software. If you have many architectures, how you can find the best software running on the best architecture? What is the right hardware for a given workload? And this is what we did several years ago for the HPC. We were optimizing code for a given architecture, so everything was optimized for that. And today we have to optimize for maybe this architecture or that architecture, and it requires really a lot of skills to be sure that it is efficient. There is a requirement for people knowing down the silicon, how it is architectured, and the software. The full stack must be understood.
And
And if
that's difficult then to be experts in both kind of the AI part and the HPC part, and that's a lot of expertise across the whole chain.
this is required, and there is a French writer called Georges Perec I really love, and who is saying constraints feed imagination. And this is key. This is, if we have more constraints, and today we have more constraints in terms of energy, in terms of efficiency, this is the first solution will not be the right one. You need to look at it. You have to investigate. You have to have the skills. You have to have the people with the right knowledge to be sure. Oops,
No, I can
sorry.
still hear you. You're good.
Yep. Okay. And to have to be sure that we can analyze and see the workload from the bottom, the microarchitecture, to the top, the production of the output.
And do you see these trends kind of continuing through 2024? This variety of chips, this the choice. I guess the what else are we seeing with the chips? The kind of the power consumption increasing as well.
It will be even stronger. There is no reason why it shouldn't be weaker. I don't see that. And if you look at the different, this is the limit of growth, I would say, on the Earth in I think 1972. But there is a limit to everything. There is a limit on Earth. There is a limit of what we will do on the silicon. So, for instance, in terms of size of the node, as we say for the transistors, we are speaking about 5 nanometers today. And after that, it's only a matter of marketing. If we say 5, 4, 3, this is just a matter of marketing. Will not go very far. So today, the only
Oh, no, I have lost you.
I don't know. He's
No, I
putting
can hear you now.
on
Yeah, you're
mute.
back.
I don't.
Yeah. Oh, we'll see if we can get the sound back from Xavier. There we go. We were interrupted in full flow as we were entering a bit of a philosophical discussion. Are you back with us? Can you hear me? No, I haven't got you yet, Xavier. No, there's some sound coming through. If you try talking
Can,
now. Yes,
yeah,
perfect. Yep,
you can hear? Okay.
I can hear you now. Yeah. So let's carry on then. Sorry about that
Yeah.
brief
Sorry,
kind of
sorry.
technical.
Last trial like this. It's good.
Yep. No, that's all good. Perfect. Yeah.
Okay. Yeah.
So, so I think we're talking around all of the different sort of chipsets that are available. This is going to become a more complex situation as we get more and more, I guess, hardware available for more specialist tasks. So with all of this choice, this massive evolution in the hardware. How do people know, or how do they make sure they're actually selecting the best hardware for these models?
They have to find again some experts, because you are facing a complexity, a full complexity in terms of hardware, in terms of software. Everything is evolving. Some things sometimes it's evolving the right way, I would say jointly, but some others this is really antinomic. So you must find the right way. And if we are speaking, if you are looking at the scale-ups I was mentioning at the beginning of this talk, in fact, their goal is not to focus on the technology that will arrive in 2 years and how to cope with that. They have to focus on their core business. And this is where, in fact, they need partners. And this is, again, what I'm trying to do, to help them and to find the right choice at the right time. For instance, if there is a new technology coming, they can say, okay, this is the right one, this is the one I want. But maybe this is a dead end. So they will invest 2 years, and it wouldn't be the first time in the computer science that you will invest a lot of energy in a technology with a dead end in a couple of years later. And so again, there is no other way than just relying on the experts from the hardware, from the software, looking at the technology, scouting the hardware, and making all this investing time for that.
And this is how we manage it in CGG at the moment then.
So exactly. So in fact, if without getting into the core activities or CGG, but what has been performed in the last decades, I would say, and all the effort that has been done to optimize the production within CGG required exactly the same skill as the one I was just mentioning. So when you have time to optimize your workload, when you have time to really at the cycle, at the cycle, I would say, you when you have time to really optimize, really fine grain the workload, then in fact somehow you have skills, really dedicated skill, and you know how to optimize for a customer. And this is exactly what we are doing. So we have a lab, what we were HPC labs, in fact, focusing on what is the evolution of the hardware, how we can optimize things to run on this hardware, and even sometimes looking at the hardware that nobody were thinking of, sorry, and then finding a way, maybe some routines, some aspects of the workload can be efficiently executed on this hardware. So this is really, we have to be open-minded, but with expertise.
And that production efficiency actually brings a competitive advantage to whoever's using it as well. You know, in terms of the time to get a result, to get that outcome, that brings the advantage. Having a result fast rather than overnight, rather than a week. That's a huge advantage as well. And I guess as well as that is doing more with the same resource as well.
Exactly. So if we have time with the customer to study and to investigate, to open the hood I was mentioning before, but to open the hood, this hood, and to look at how to optimize things, and then get a factor of magnitude efficiency, then the question is, where is the benefit, or who takes the benefit from the customer and from us? Obviously, there is a competitive advantage. If instead of spending one night you spend 1 hour, or if you're spending 1 week you spend one day, and then on our side also we can use less resources, and we get more results in the same amount of resources, I would say. And then this is the model we are saying, which is outcome as a service. The question is, what is the cost of producing one outcome? And if we are able to optimize this, the cost of one outcome, then everybody benefits from that, and we can have a partnership to optimize further.
And it's not just around just the time to a single result, because it may actually be the energy to produce that single result that we're optimizing perhaps for energy rather than for time. There can be a number of different metrics there that we can optimize for.
At the HPC lab, I was reading something that the expert has written about how to have the best energy to result for a given architecture, and even for a specific architecture, the way to use it is not straightforward. You can say, okay, let's fulfill it with everything, but in fact it was not the most efficient because of memory bandwidth and things like that. In fact, you can just reduce a little bit how you load the machine, and then everything is more balanced, and then the energy is more spread, and everything is more so smooth, I would say. So again, energy, so you have to know the constraints that you have, obviously, on the workload, and you have also to identify what is the key the performance indicator that you want to apply, and then focus on this one, because energy is maybe if you are selecting on energy, maybe you will not focus on time, and you will have worse time to result. You can see everything is a balance, and you have to find the right key performance parameter.
But that overall optimization is the more responsible approach overall.
Yeah, the less you consume, the better it is.
And that's equally valid for whether it's an AI workload, or I'd say maybe a more traditional HPC workload. And I guess we've got many examples of that in practice, whether it's from our own internal works or the work we do with our clients as well.
Yeah. Yeah, we did exactly what I mentioned, or what we are discussing today. We did exactly that for a startup, in fact, where we optimize for an order of magnitude the results. So, and again, for them, they can focus on the science, they can focus on what they want to produce. On our side, we are focusing on making it efficient and getting a competitive advantage thanks to this outcome as a service.
And we've also reduced the amount of resources they're using. So
Yeah.
overall, they're a much more responsible operation. So everyone wins. So we've covered quite a bit on the topic of responsibility. In terms of 2024, what other trends in AI should be on our radar?
So for me, the evolution of the AI is really on the architecture today. Again, we've got huge network, and now we start to split these networks in different parts. And this is again what has been already done by Mistral, which is a French company, I would say now, with what we're calling mixture. I don't know how to pronounce that. Mixture of experts. Vigouroux is hard for you. A mixture is hard for me. So the mixture of experts. So how, instead of having a monolithic architecture, how you can specialize some parts, some components for some things. And there is one thing which is, this is why I like 2024, is that there is a book that has been written in 1986 by Marvin Minsky, who was the director of AI lab at the MIT. And he wrote this book in 1996 with a totally different context. And there was this notion of agents that would interact, how you make agents interact. And this is what we're seeing in AI today. How you can say, this one will focus on that, this one is focused on that. And maybe we have to see the conflict between them. How do we manage the conflicts between them? How we specialize them? This is really interesting period for that.
Oh, that's exciting. Is there any other particular aspects you're looking forward to in 2024?
Something that really attract me, but personally, this is the robotics. I must mention the robotics, because today, again, if you compare what we can do in text, what you can do in image, with all the stable diffusion and all this the generation of images, you can see that the robotic is a little bit lagging behind. And I'm pretty sure there will be a huge evolution of the way we can see robotics interact, etc. I think I really enjoy that again.
Oh, no, that's going to be really interesting. But I wonder when I'll be able to sort of interview a robot on the couch rather than a human. But I appreciate you joining me as a human today, Xavier.
Thank you.
So thanks everyone who's joined the live stream or the recording of this afterwards. Apologies again for the bit of technical glitch in the middle of this. If you've got some questions for Xavier, then reach out on LinkedIn or drop us a line. If you go back to the LinkedIn page, you'll see a form where you can sort of reach out to us. And if you'd like to see how we can help make your AI more responsible, then get in touch. Keep an eye out for our next topics. Over the next year, over 2024, we're going to celebrate some more of the people that make our business happen. And we'll certainly dive deeper into this topic of environmentally sustainable data center operations as we explore our latest HPC hub. So it's going to be a good year. I look forward to seeing you next time. Thanks, everybody. Thanks, Xavier.
Thank you, Sharon.